Have you ever watched a line of ants marching with incredible precision and wondered, how do they do it? They look like they're just wandering, but is it all random? It's a question that has fascinated scientists for centuries. Today, we're diving deep into the mysterious and surprisingly complex world of ant navigation. Get ready to have your mind blown by these tiny geniuses. Let's get one thing straight right away. Ants don't just wander around hoping to bump into food. Their journeys are incredibly deliberate. When you see an ant moving, it's often on a mission, following a highly structured plan. They are expert foragers, and their ability to find the shortest route back to the nest is nothing short of extraordinary. They might seem like simple creatures, but their navigation skills are among the most sophisticated in the animal kingdom. Think of them as tiny explorers with a built-in GPS that humans are still trying to fully understand. So, what's their secret? One of their most famous tricks is the ant trail. When a scout ant finds a food source, it doesn't just keep the good news to itself. On its way back to the nest, it leaves behind a chemical trail of pheromones. It's like leaving a trail of breadcrumbs, but instead of bread, it's a unique scent that says, "Hey everyone, follow me. There's a feast this way." As more ants follow the trail, they reinforce it with their own pheromones, creating a superhighway of scent that guides the entire colony to the food. If the food source runs out, they stop leaving the scent and the trail eventually evaporates. It's an incredibly efficient and self-regulating communication system. But what about when an ant is exploring new territory alone, with no pheromone trail to follow? How does it find its way back? This is where things get even more fascinating. Scientists conducted an experiment with desert ants. They let an ant walk from its nest to a feeder. Then, they either attached tiny stilts to its legs or shortened them. The ants with stilts overshot the nest on their way back, while the ants with shortened legs stopped short. This led to a mind-boggling conclusion. Ants can count their steps. They seem to have an internal pedometer that measures the distance they've traveled, allowing them to calculate the return journey with remarkable accuracy. It's a simple yet brilliant mechanism for measuring distance. Counting steps is great for distance, but what about direction? For that, ants look up to the sky. Many ant species use the sun as a compass. They are sensitive to the polarization of light in the sky, which creates a pattern that they can use to determine their bearing. Even on a cloudy day, when the sun itself isn't visible, this internal celestial compass allows them to maintain a straight course. By combining their step count with their solar compass, an ant can calculate its exact position relative to the nest. This is a process called path integration, and it's essentially a form of dead reckoning. Just like ancient sailors used to navigate the open seas. But ants don't rely on just one or two tricks. They are multi-talented navigators. In environments with plenty of features, like a forest floor, ants also use visual landmarks. They can memorize the skyline, the position of prominent trees, rocks, or even man-made objects. Before entering their nest, some ants will even perform a little turn-back tan-look maneuver, essentially taking a mental snapshot of the surrounding scenery. This helps them learn what the entrance looks like from the outside, making it easier to find on future trips. They build a cognitive map of their world, much like we do when we learn our way around a new city. Of course, even the best navigators can get lost. So what happens when an ant's calculations are off or a landmark has been moved? They don't just give up. When a lost ant realizes it has overshot its destination, it doesn't wander randomly. Instead, it begins a systematic search pattern. It will start with small loops, gradually expanding its search area in ever-widening circles or zigzags. This strategy maximizes the chances of re-encountering a familiar scent trail or a recognized landmark without straying too far from its presumed location. It's a very logical and efficient way to correct errors and get back on track. It's also important to remember that the world of ants is incredibly diverse. With over 12,000 known species, it's no surprise that not all ants navigate the same way. Desert ants, living in a visually sparse environment, might rely more heavily on their sun compass and step counting. In contrast, leafcutter ants, which create massive, well-trodden highways through the jungle, depend heavily on their powerful pheromone trails. Some nocturnal ants even navigate using the moon. Each species has evolved a navigation toolkit perfectly suited to its specific environment and lifestyle, showcasing the incredible adaptability of these insects. All of this complex behavior is coordinated by a brain that's smaller than a pinhead. The cognitive power required to integrate information from step counting, a solar compass, and visual memory is immense. Scientists are studying the neural circuits in an ant's brain to understand how it processes so much data with such efficiency. An ant's brain may be tiny, but it's a marvel of miniaturized computation. It proves that you don't need a large brain to be a smart and effective navigator. The way they solve complex problems with limited resources is a true inspiration. So why should we care about how a tiny ant finds its way home? Well, the principles of ant navigation have huge implications for our own technology. The way ants collaborate to find the shortest path has inspired powerful computer algorithms, known as ant colony optimization. These algorithms are used to solve complex logistical problems, like routing trucks for delivery companies or managing data traffic on the internet. Furthermore, by studying how ants navigate, roboticists are developing more autonomous and robust robots that can explore challenging environments like disaster sites or even other planets without relying solely on GPS. So, to wrap it all up, ants are far from being simple, random wanderers. They are master navigators who use a sophisticated combination of chemical trails, step counting, celestial cues, and visual landmarks to traverse their world. Their ability to find their way has not only ensured their survival, but has also provided us with brilliant solutions for our own technological challenges. The next time you see an ant, take a moment to appreciate the incredible journey it's on. It's a tiny titan of navigation, executing a complex plan right under our noses. Thanks for joining me on this deep dive into the world of ants. If you found this as fascinating as I do, hit that like button and subscribe for more adventures into the amazing world of science. See you next time.